Okay, let's discuss the how problem of learning, how to perform machine learning. Let's consider a very intuitive example. Say this is an intelligent dog, and the dog has some observations of the world, and her data consists of the stimuli, her action, reaction of the stimuli, and what is the reward. So in this intuitive example, the dog is going to figure out how the world works, which kind of stimuli and action combination may bring back some desirable reward. We will discuss this problem at two levels. The first level is relatively straightforward. We will discuss the practical procedural design of a learning system. If you have learned a bit data analytics, this part should sound familiar to you. On the other hand, we will also consider the theoretical components in this problem and how this component works with each other. For this, we will have a more detailed discussion. I think you will need to watch this and the next few video clips. Okay. So the procedure of learning. In this figure, I use blue boxes to represent entities, something that is tangible, that is stored in a computer memory, like data or program, data, sorry. And the green boxes represent operations. Solid arrows represent information flow, and the broken lines represent dependency relationships. So given the data, to perform the learning, the first step will split data into two parts. One part for training the model and the other part we withhold for later evaluation. Using the training data, we will train the data model, and the training operation has other names such as learning, such as fitting to the data. The training is designed with respect to your understanding of the task and your expertise about how to do model selection, this kind of decisions. And of course, the decisions will be based on your understanding of the data. After training, after you have fit your model to the data, this procedure, this operation will return you a model, and the model will summarize the knowledge that we extract from data and will be used for future prediction tasks. Then we use the evaluation data that we withhold to test the model using some evaluation procedure. And according to the result of the model evaluation, you may make decisions whether to go ahead with your business plan, or you might want to come back to your whiteboard and do anything from scratch. So this is the procedure. Now let us focus on this part, the training part, how we formulate the training solidly in a digital computer. Come back to the intuitive example. Consider our intelligent dog. When facing the black box reality, her task is to figure out what is going on in her owner's mind without any directly rules. The only window to peek into this black box is through the data, which is what stimuli and what reaction brings what kind of reward. So our dog will have her hypothesis. Okay, maybe this thing flies over in front of me. It's a good idea to sit here and this will bring me back this yummy reward. This kind of thoughts. Then it compares her hypothesis to the data with respect to some criterion. Well, the real experience is that when I'm saying this and doing that, the reward is yummy or nothing. Okay, so this is one part, one element of this learning process. In reality, the thing goes a little bit more complicated. Instead of a single hypothesis, intelligent creatures, in her mind, there must be multiple candidate hypotheses simultaneously exist. So the learning is to compare those hypotheses with respect to the data according to some criterion. And in this the selecting operation is what we normally call learning. Learning returns you an optimal hypothesis that has been selected from the hypothesis family best fit to the data. So here is a summarization. In the learning framework, we consider 4 elements. The black box data distribution, which is unknown, but we can have observed samples as partial information of this unknown process we would like to learn from. And we explicitly assign some hypothesis family. This is one bit we need a little bit more consideration. Recall that the goal of learning is to build a mapping from the observation space X and the target space Y. But it is generally not so helpful if we consider the generic mapping from X to Y directly. We will come back to this point very shortly. Maybe that shortly. We will talk a bit in the rest of this lecture, and we'll come back to the topic weeks later. So anyway, we would like to constrain ourselves within some hypothesis family and perform learning only in the limited hypothesis candidates. Within this explicit range of hypotheses, we will select one of them according to some criterion, and that is called learning.